Good afternoon, everyone. Today, we have a hands-on experience on LSA using SVD, and we work with the actual text document. Okay, having said that, please go to Databricks and load LSA in Jupyter Notebook that I have shared last week. Also import sample underline text.csv. All of them are loaded on previous model. So if you go to model, week 12. So please load the sample underline txt.csv, and also we keep working on LSA Jupyter Notebook. But on top of that, was loaded previously, load sample underline text.csv from week 12. Also for this week, I put a PowerPoint in week 13. You can download it too. I give you a couple of minutes doing that. Okay, so in this session, we have a data frame. It has two columns. The first, some sentences, and the second one from the book that those sentences are acquired. So one of them is Charge of the Light Brigade, and another one is the Raven. So we do some text mining specific function. So for being able to do that, you need to work with NLTK package, which is not a default package in Databricks. Therefore, you need to install it. So I put instruction for installation. So if you're for your own project, you need to install other packages. It's the way that you need to do. So I also upgraded the pip too. Sometimes you have to upgrade your pip installer, and basically from NLTK, I'm just installing every possible thing. So for being able to run the next code, you need to run this groups and networks, so you can have the NLTK package installed on your Databricks instance. Just keep in mind, every time you make a Databricks node, you have to install the package, because this package is installed over a specific instance, not whole of your Databricks account. Yeah, it might take like 1 or 2 minutes, so I wait for all of you to install the package. So in the next part, we want to work with the stemmer. Basically, a stemmer just gives you the stem of each word. Having said that, like saying, say, or they might have, both of them has the root of say, S-A-Y. So maybe it's more efficient that instead of focusing on, and instead of having different format of say or any verb in different times, it might be efficient to just focus on a specific, on their own roots or stem. But sometimes these packages are not very efficient or very correct. For example, look at the sentence. My sentence is, I charge for the guns he's saying. Okay. So if you see, I use Porter stemmer, so it didn't find the charge root, so I just put charge. And also, but for saying, you see the stem of it's a stem which is say. So it's not may not be always correct. Sometimes it has some issues, but it's the best things that we have so far. I also use word tokenizers, so I focus on each token. These are just sample stemming tokenization codes. So as you see, I made a for loop for the words, or for the tokens of the word. So this time, look, instead of having charged, I have charge. So, but you may say it's not very correct, but it's I'm just showing you that this approach may not give you the very correct ways, but this is the best things we have. For example, guns, instead of having guns, we have gone. So also saying, for saying we have its correct stem, which is say. So second time, I first basically tokenized my sample text and basically then focus on each word and try to find its stem. As you see, you might find some issues, but again, this is the best things that we have. Hopefully, next updates, they take care of the past tense, and other format of the verbs. Okay, let's focus back on the text that I just imported. So you might remember with UDF, I can make my own a user-defined function. Here I'm defining a lambda type function, which is basically brings back the stem of each word. So then I focus on my document, and I make a word vector stemmed column using the sentence column. And basically the vector stem column, it just means I'm applying a stemmer UDF function that I define. So basically the vector stem column has, I hope, which actually it has. So it has the root of the tokens of those sentences. Still, you might see some issue for the sum of the words, or basically tokens. For example, for say, a say is not in the stem format, or it's in its root format, but it's what can we do. Also, as you see here, I converted my data frame to a Panda format, and it's just basically NLTK is a Panda-friendly package. So for being able to use NLTK functions, for most of it, you have to convert to the Panda format. So not a big thing. And also, we replaced the sentence column with the vector stem column that you already had. And I'm just showing the 5 sample sentence that I do have. So as you see, those 5 are from Ravenbook and Charge of the Light Brigade. Also, I keep the index of those 5 sentences. Later, I just want to see what happens when I apply further functions. I give you a couple of minutes if you want to put some comments or have questions, then I go to the next part. So, but how you can make a comment? If you see with the hashtag, you can put a comment. Also, so you can put a comment block. So that's another way of doing it. So these are, let's say, these are a comment block. If you double click on it, you can see how I created. So as you see, you can put MD command, means markdown. With MD command, whole of the block tends to be a comment block. So in case you want to put put several lines of comments, it's the way that you can. Okay, so as we talked in the previous session, stop words doesn't have any sentiments. These are some extra tokens. And each token later would be a column as you can consider as a variable. So these are basically some extra tokens or later variables that we can get rid of it. So with count vectorizer, I'm just saying that I want to basically focus on 2 things. First of all, the tokens should be at least attend 1 sentence, and also I want to get rid of English stop words. Then I applied my unsentence column. So, and I make a bag of the words. So bag of the words are basically the sets of tokens that I can later use for decomposition of my sentences or basically body, and using them for for applying machine learning algorithms. So far we brought a sample data frame consists of sentences from different books. We tokenized it, and also we got rid of stop words. Let's try singular value decomposition, or SVD. So what we want to do, basically, use a SVD method which has 2 components or 2 variables, and see how it works. So if we just use 2 variables or 2 components could we have a good differentiation between two sentences, or if having two components is enough good or not. So we named these two components as topic 1 and topic 2. And also we make a sentence column, which sentence column just means the actual sentence that we brought. And also add a new column is Raven. So as you see, I'm saying that if the title equal Raven, these conditions has two outputs. So if the title is actually Raven, it brings true. If that condition isn't true, it basically returns false. So it's the reason here you have isPoem column. It just have two values of true or false, because this it made out of this condition. And also, I already took 5 indexes, and I'm just showing that. I'm just showing those random 5 sentences. Not actually random, actually the top 5. You can also later make random indexes, but it's just saying that, okay, we have 5 sentences. We can, instead of having back of the words at the representation, for the representation, we just use 2 topic or components for representing each sentence. Also, we have extra column, which means if the sentence coming from the Raven book or from the other book. So here, just show you basically the dictionary that we have. These are the words that before SVD or on top of SVD, you can use these words for representing each sentence. So if these words attends or exists in a specific sentence, this associated value would be 1, otherwise 0. Also, I'm just showing the top 5 tokens for representing all the sentences. Here also, you can look at the representation of each token through SVD components. So we have 411 tokens, and it just show how each token represents through that 2 components. It's just for visualization, nothing much. I just want to show how these 2 components represent each tokens. Now I put them in a basically dictionary table. So as you see, for each term or token, I have topic 1 and 2 that represent them. For example, the term of adore or token of adore, as you see, is with topic 1 is 0.0016 something, with topic 2 0.0057. If I recall the previous class, so each term or token could be represented by 0, 1 each sentence. Here, we did actually showing it opposite way. We want to just see how those SVD components can represent each term. Yeah, give you a couple of minutes in case you want to put a comment on your Jupyter notebooks. Then I go to the remaining blocks. Okay, before going to the next block, let's talk about SVD more, just recall what we had. So, since for human eyes, usually we use 2 dimensions. At most, we can kind of work with the 3 dimensions, but more than 3 dimensions are not healthy. So, look at this example. Just assume there is imaginary line and all of my points are on this imaginary line. Let's say some of them are circular, some of them are cross. Like here, we have 2 types of text from 2 different documents. One of the Raven book. What was the other? The charge of the brigades, I guess. What's that? The charge of the light brigade. The charge of the light brigade. So it's like here. So we have 2 labels for each book. So if you remember in SVD, we can use less amount of vectors or dimensions to represent our documents or information. So what if I just use X and Y here? What happens? So here, if I exclude Z, all of X and cross and circle would be located in just 1 point because we don't have any Z to differentiate. So maybe here, instead of using X and Y for summarizing the information, maybe it's better to use X and Z. So if you use X and Z, so you might see all the points. So we want to have similar experiment here. So what in the next few logs, what I do, so I just pick 2 topic and show you what happens if you want to represent all of our documents to 2 vectors. And then I change those vectors and see how they represent my sentences. The goal is showing you you shouldn't just use SVD and just apply machine learning. Sometimes you might end up having this situation. So even if you use the most complex algorithm, since your data preparation here SVD is not good, you cannot have a really good model. So in each step of your project, you need to think, just dive into your data and see what you are doing. So you shouldn't just close your eyes and apply every algorithm randomly. Oh my God, your friend over Zoom couldn't see what I said. Okay, anyway, so look at here. I'm just basically, I got rid of the sentence column. Sorry, here I just focus on the dictionary, and I make an absolute value of each topic. Here, topics are basically my dimensions. So first, I'm sorting based on absolute value of topic 1. So if I sort based on that value, look at terms, door, chamber, makes sense. They could be kind of related, so it makes sense if they have higher value for certain dimension. Boss, bird, tapping could be, but I think burst and bird is not very intuitive if they have high value in topic 1. and be close to door and chamber. Let's do same thing for topic 2. Bird, profit, say, maybe profit and say could have closer value, but bird, I'm not sure. Think, evil makes sense, kind of, but some of them doesn't make sense. So here we see some possible issues, but let's just plot out that, see what happens. So similar to the experiment that had here, so we want to plot our labels into the 2 dimensions. And again, I'm using 2 dimensions because it's easier for human to just imagine what we did. Okay, so I'm looping over the values that I have in basically my label. So is poem unique just means the unique value of is poem column. So is poem column just have true or false. True means is Raven, which is poem book, and the charge of the brigade is the other book. So first, it just the value would be true, and so if the value is true, it picks the color of blue. And also the legend would be the Raven. It's the label that we have. So we doing a scatter plot of topic 1 and topic 2 as my X and Y variable. With each time the color would be the color picks from here. So as I already said, my value has just 2 values, true and false. Which true means blue, otherwise red. Also, I added the legend. In case you forget Matplotlib, please just do a quick review. I think if you Google it, you can get a lot more from the function. But anyway, so let's look at the figure. If you zoom in, so let me just zoom a little more. It's very hard to see charge of the light brigade. Maybe one here, you can see another one here. So it seems topic 1 and topic 2 as my 2 dimensions couldn't differentiate these 2 topics very, since several of them overlap to each other. So it's even very hard to see those red, which for me look orange. I'm not sure if I have color blindness, but doesn't look that much red to me. But it seems that 2 topics overlap too much that even you cannot see any red circle. Is that exactly the issue that I just showed you on the whiteboard, but could be used to topics that are not very well differentiated? For example, in this case, maybe just see 1 point, but doesn't seem this is 1 point. Maybe like 200 points just overlap each other because of bad dimensional selection. Here we don't have 3-dimension to 2-dimension. Each of the words is a dimension. Maybe we compress maybe 200 or 400 words to just 2 equivalent dimensions. But the issue could be similar. We just don't have a good dimensions. Okay, I give you a couple of minutes in case you want to put a comment. Then I go to the next blocks. Again, if I teach very fast, please let me know so I can stop more or explain more. Let me stop share and take explain for your friend over Zoom in case they couldn't see and they don't ask any questions. So. Okay, so what I told to your friends let's say this is X, Y, and Z, and I showing cross and circles with these 3 dimensions. So you can easily differentiate. In SVD, let's see. In SVD, we try to use less amount of dimensions because each word could be a dimension. So what happens if instead of X and Y and Z, we just have X and Y for representing all the points? As you see here, if we exclude Z, all the points happen to be overlapped on just one point. Doesn't mean they're actually overlapped, but we have less amount of dimensions. So it just seems if I use X and Y for basically for reducing number of dimensions, I did a really bad job because I cannot differentiate between points. So what if instead of X and Y, I use X and Z? So as you see, still I can differentiate between my points. So same happened for your previous blocks. So I had 2 dimensions of topic 1 and topic 2. I tried them to represent all of my sentences, but when I plot them, it seemed based on the plot, it seems I couldn't differentiate that much between 2 different labels that I had. So I had, or I have, topic. One of them is the Raven, and the one Charge of Light Brigade. These are my labels. Almost all the points overlap to each other, and more specifically, the Raven just cover almost all the Charge of the Light Brigade. It seems that application of SVD didn't work. So let's say in the next step, you want to do prediction. You want to predict the label, is it the Raven or is it the Charge of the Brigade? So since you did a very bad SVD implementation, your model shouldn't be good. Okay, this time, before SVD, maybe we can use TF-IDF. Let me recall TF-IDF. So in TF-IDF, instead of assigning 0 or 1 to each term or tokens or words, for some of the tokens, we give value more than 1, or we give them more importance because of their appearance in some certain documents or whole of our body. So exactly same as before. So for this time, I applied TF-IDF vectorizer. Again, I want to exclude the stop words, and each token should appear at least in one document. And it's after applying on my data frame column, sentence is the column from body underline df. I make my back of the words. This time, still I just use 2 topics when I want to apply, or here you can call it components for applying SVD. And then I applied over back of the words. Also, I just show the first 5 topics. So let's look at 2 ones. See, for box is kind of challenging. Sometimes you have negative and positives in a little different format. Okay, let's this time sort based on, I think here I didn't sort. Yeah, here I just put them there. Yeah, here I just sort them based on the absolute value of topic 1. So nervous, code, raven, shell, bird, said. And let's again sort based on topic 2. So rude, boldly, wandered. It seems there is more logic in terms of the words that have similar values. This time, I just want to show you two different plots. One created from simple SVD. In the next one, I use TF-IDF vectorizer. So again, it's what you saw before. So you have a lot of overlaps. Now this time I did exactly the same thing, but I basically topic 1 and 2, which are the components of SVD, are different because I use TF-IDF. So look at the charge of brigades. You see 2 points, but maybe there's a lot of overlaps, or maybe many of them are in the 0, 0, but at least you have a better separation between the two labels that I had. Previous one, it seems there's some randomness, but here it's at least you see a better differentiation. I said you might just see maybe 2 green points and maybe 8 red cross, but these are actually many of them just overlap. And if you look at again here, let me just bring the sentence. Look at the value 0, 0, 0, 0 something. So the values are even very close. Many of them are close to 0. So might be, it's better to just zoom out, but still, it seems to be a better differentiation between that two labels that I had. So this is your next homework. So for the next homework, you have the same, basically, body. Again, body just means a data frame that you have several sentences. Each sentence is a document. All of the data frame is a body. So these are just technical terms. So let me just go back where I imported the data. Okay, you need to import the data. And you might do several data preparation, like tokenization, TF-IDF, SVD. You don't have to do SVD. Even you can do feature selection. So each word is a variable. Sometimes I go very technical, use very technical terms, but word or tokens. So what should you do? You should predict the title column. You can, again, you don't have to do SVD. You don't have to do TF-IDF, but might be better. So at least try 2 different ways for better prediction. If you couldn't, that's fine. So the goal is predicting, using those sentences, trying to predict which box they are coming from. The easiest way of doing that, maybe use my notebook. Trying to find, okay. Maybe you can use my notebook and first use just topic 1 and topic 2, try to predict the column. Maybe you use SVD and also tokens together. So you don't have to just use 2 variables for prediction. Maybe you use several tokens, topic 1, topic 2, and maybe you do feature selection. So there, I mean, I don't care how you do that, just use 2 different approaches for predicting the poem, for predicting the title, actually. So you can look at the previous notebooks that I shared with you, because I thought about feature selection before, not in the text mining. So you can merge those codes and do feature selection. So again, at the end, you should use 2 different ways. Try to predict the title column. If you can have improvement, that's good. If you cannot, that's good too. I just want to see you use two different approaches. So any question about your assignment? I haven't posted yet, but I'm going to post today. But use PySpark, don't use, or Spark R. You can use a Spark R too, that's okay. But don't use Python or R independent from Spark environment. Okay, I'll give you a couple of minutes. If you have questions or you want to put comments on your notebook, then I go to the next topic. But it's strongly recommend to put comments, especially these new codes. I share the video later, but if you put comments, you don't have to see the videos. You can just look at the comments that you put. So it saves a lot of time. Okay, the next topic is about Kafka technology. So I intentionally put it almost one of your last topics because it's not that much relevant to your project. I first wanted to share several codes and you learn how to do your own project. Then if you have extra time, I go back to another technology under Hadoop ecosystem. So Kafka is one of the most advanced one. The goal is basically, I put the goals there: publish, subscribe, messages. So you might have several streams of data and also several customers or several applications that work with the data streams. Kafka just helps you and saves a lot of time. If I want to do a comparison, let's remember when we wanted to MapReduce with Python was very hard, but we have seen that Hadoop helps us to do MapReduce. Here, in my one of the classes, I show you how to work with the Twitter stream. And it might have, actually Twitter stream is not a very good example because it's not too difficult. But most of the time, working with the data streams is really hard. Still, Twitter is not very easy, but it's not very hard too. But what if you have several streams and you want to merge those data streams? One of the good applications is, let's say you want to do trading, and let's say you want to do Bitcoin trading. So one stream could be text document, one stream could be gold price, Ethereum price, maybe stock price. and you name it. So you might have several streams of data. You need to basically kind of measure them together, train a good model, and do the good prediction. I tried to do that without Kafka. It just took a lot more time. So Kafka is just a good tool, so that helps you to work on the streams of the data. So can you guys tell me other businesses that work with the stream of data? Huh? Yeah, Facebook could do one, yeah. Maybe even Uber or any transportation company. So transportation companies have the trucks information, weather information, and customer, not that much. Customer, maybe they do not that much of a stream, but trucks, weather, and roadway situation is the streams that they have. The goal for them you might remember we had a transportation problem in your business intelligence class. So the goal for them is minimizing the cost. So they might look at different streams of data and make instant decisions. So except for the Twitter experiment, so we work with the basically data frames. Data frames are historical data that are set somewhere, and which we have seen Hadoop file system or HDFS helps you to have a resilient or fault tolerance distributed data processing. But especially more recently, we have several streams of data. Here I put some of the streams like web server information like Facebook, Uber, Internet of Things or IoT. So you might have several sensors working in the manufacturing plant or everywhere. So these are not every second, but that's based on the time you need to send you some information. Or I talk about stock trading. So these types of data needs more specific attention. And believe me or not, if you don't use Kafka and just try to use Python to analyze those data streams, it takes forever. But just Kafka helps you to manage it in the most efficient way. So Kafka is not a model or machine learning approach. It's basically just a vehicle. Or better term, maybe just a like message center or just message management system or stream management system. For streams of data, we have two issues. First, how to get the data, how to distribute the data. So let's first focus on how we get data from different sources. So basically, Kafka manages different time units of the streams. And basically, they have some protocols that let them to communicate with the publishers. Publishers are just basically stream sources. Gets those data, put this basically a manageable format, and just send it through customers that need to process the data. So it's not Hadoop specific, but highly implemented through Hadoop and Spark environment. So for Hadoop, you already learn about the advantage of Hadoop. So Hadoop is basically, if I tell you a very basic definition, it just basically is a management system that helps you to manage a very big amount of data in the resilient and fault tolerant way. Do you guys remember why Hadoop was fault tolerant or resilient? Exactly, very good. Thank you. So Hadoop copies your data on several data nodes. So if let's say, or for example, Amazon has your information on several data centers or nodes. So let's say if they have a Boston node and Boston node ran out of power, maybe they can connect to New York node and basically they process your order. So if they don't use Hadoop and one of their data nodes get broken, they get out of business. So they don't want that happens. They want to have fault tolerance or resilience. So in that way, Hadoop is very beneficial for Kafka because the goal of Kafka implementation is just making efficient business decisions that needs streams of data. Also, Spark has some capabilities that help you to do basically on-spot or online machine learning analysis using the stream of data. So Kafka, Hadoop, and Spark integration are really useful for the businesses that work with the streams of data. So let's say we just have one data transaction just from Twitter to your own computer. Still, maybe you can use Kafka, but you don't have to. Like we had a Twitter experiment. So we just have a Twitter API connect to Twitter and gets the data. Still, having Hadoop ecosystem helps you to manage a large amount of data, but you don't see that much of advantages. Look at this one. What if you have several applications, one Twitter, one stock, one Bitcoin data, so weather data, so you have several data sources, and you might have several even applications, several consumptions. So one could be, for example, I talk about truck business. Maybe or maybe Uber. So they said, let's say there's an event, baseball or football. So you might know that, let's say if there's a big game in Boston, the Uber maybe gets 4 times more expensive. So what they do, they basically manage the like events information, weather information, passenger information, driver information. So they get data from different sources and send data to different sources. So without Kafka, it's just a mess. It's very hard to manage all of them. So the integration part of Kafka includes several protocols or data formats. For example, I'm pretty sure you heard of HTTP. You might heard of REST. These are some internet protocols. Also, we have different data sources. It could be in the binary format, 0, 1, JSON, CSV, and different schemas. So again, if you forgot, so anyone remember what was the schema? Huh? I think you're in the right path. You talk about data set variables. So the schema just say what is the type of each column. For example, in Titanic, one of them could be integer and the one could be text document. Yeah, so string. So basically, Kafka just helps you to work with the different manage different protocols, different file format, and different schemas all together. I'm pretty sure if you want to do something like trading analytics or like a stock or Bitcoin, you can see managing these different protocols and files is really hard. So if you do that, you appreciate Kafka much more than this. So look at what it was before. So we have several communications, several like file format. Now there's a Kafka, which just gets the data from different sources, manage, and just send back to different customers or applications. Also, your consumers could be in different groups. So for each group, they might get, instead of for each consumer, you might have customer group that they might get similar data. So consumers within each consumer groups maybe send and receive similar types of data. Okay, so hopefully by now you have seen the some advantage of Kafka. It's created by LinkedIn now, which is, I think, since Microsoft acquired LinkedIn, it's probably part of Microsoft right now. Also, is maintained by Confluent, which is again private institution. So Kafka, more specific, Kafka through Hadoop, has resilience and its data is distributed. Therefore, it has a fault tolerance. It's highly scalable. So you might have several data resources and customers. We have a high throughput. You can send millions of messages. And more than 2,000 companies, at least 35% of Fortune 500 companies already adopted Kafka. So as a part of business, like Walmart, Netflix, LinkedIn, Uber, Airbnb. So is there anyone can tell me how Netflix can use Kafka for, or data streaming in general for their own business? So the stream doesn't need to be every second. Maybe every day you just use Netflix twice, but these are, you can consider the daily streams. Not, doesn't have to be second by second.
And one of the current topic I kind of noticed on the category on the Netflix is that what's the current hot topic in the world, and they somehow upload or recommend that topic on documentary on Netflix now.
Yeah, correct. I mean, the goal is just having you use Netflix more. Actually, I already unsubscribed from Netflix because I didn't like it. So they want to keep you watching. So you need to be satisfied. So they look at your, how you watch other Netflix shows, and basically if you, and they might recommend new shows to you, or try to have some ads. So sometimes when you watch an episode, it's just a little bit of advertisement. So yeah, they need to have you manage the data that comes from your systems, either like TV or browser or cell phones, and end up deciding if they want to invest on certain topics. And also they can predict which kind of basically movies or series you want to watch more. So if they make some decisions, how should they invest on some certain types of series or movies? So have you guys watched Squid Games? Is it a good one, or I have? It's okay, but it's I think it drag a lot of attention.
If you've ever seen like any other like that game show like that, it's kind of generic.
Okay.
Ending is like annoying. It's okay. Those are fun.
But yes, I think I see they make a good amount of money. Because I was thinking of subscribe back because I had a lot of comments from people watch Squid Games. So
Ryan Reynolds has a very Deadpool kind of feel.
still, there's a lot of, I mean, you guys talking about that show, it seems you watched that. So they made a good decision in investment. So maybe you don't like it, but still you watch it. So yeah. So Kafka is a part of Apache project too. So it just means you can integrate with other Hadoop ecosystem technologies, including Spark, Flink, Storm, Hadoop, or other big data types technology. Again, Kafka is a little higher topics. So it's kind of this session, next session would be kind of optional, but it's really good to learn something about Kafka. Yeah, these are the different applications of Apache Kafka. So recommendation for the Netflix, like trips, customer and pricing for Uber, for LinkedIn. So different interaction or messages people send to each other. How much time we have? I think we have a little bit more time. So let's talk about some technical terms. And this project kind of developed first separately. So it's just when they merge together under Apache umbrella. So you might see several technical terms. So first, topics. Topic just means a stream. So in Kafka documentation, when they say we have several topics, that just means they're talking about several streams that could come into your Kafka application. And each stream or each topic has some certain names. Also, streams are stored or basically distributed through partitions. So it might be a little tricky. So you might remember in any basic computer class. So your hard drive is divided into several sections. We call them partitions. So Kafka streams are in several sections. We call each partitions. So in hard drive, when you save some data, your data would be saved in a very random order. It's random for you, but maybe for complete want to expedite the read and write process. So it doesn't care. So it may be basically your data would be divided in several sections because fast for your hard drive is faster to read. Same happens here. So if you don't identify your partition ID when you do a streaming, your stream might go in the random partitions. So you need to have, when you want to do streaming, you need to identify partition ID, or you can consider as a channel. I think if I say channel, it makes more sense. So you need to specify the channel that you want to stream. Otherwise, your just data or topic would go to the random partitions. So one of them could be Kafka wants to expedite the streaming process. So when you don't identify the partition ID, just send randomly to the one that has a faster throughput. So like here, let's say we have a trucking company and you have several trucks and they send a stream of data or let's say topic. So each truck send a topic or a stream to Kafka. And let's say you have 1,000 topics. So when you want to manage them together, you might divide those 1,000 trucks into 3 partitions, 10 partitions, 2 partitions. Partitions here just means channels or how you manage your streams. For this example, I said, okay, we have a trucking company, we have several trucks. I just want to divide my streams into 10 partitions or 10 channels. Number of them is arbitrary, so you can decide on several partitions as you want. Also, we have a term of offset. So looking at the 3 partitions that I have, so the data would be sent in a specific order. For example, if you are talking about truck, so first order, maybe in every 10 seconds, every second, or every 1 hour, you send, not 1 hour, maybe every 1 minute, you send your truck information. So each block that you see on the board could be a location of your truck on certain time points. For each partition, we have an offset number. It just means index number. So later you want to search through your stream. So if you want to have them in order, you have an offset number. So it's just a technical term for ID number or order number. And just keep in mind, basically, in contrast with the hard drive, your data is immutable. It means when you send a stream or topic, I mean, in the beginning, I give you the 2 term because the stream and topic is the same, but later I just say topic. So each data in each topic is you can consider as a tuple. So you just can read. So if you have offset number, you can read the data, but you cannot change it. Also, we have another technical term, brokers. Brokers, it just means servers. So if for having distribution and fault tolerance, you might have several nodes. Each node has a server. So instead of saying server, we call them broker. And in each node, if you have several, this is like Kafka specific. So if you implemented Kafka, if in each node you have several servers or broker, if you have access to one of them, it just means you can access to several brokers. All the brokers in one node are accessible if you have just access, even if your access identified to one of them. I think it's good for today. I think I taught too much. So next class, I keep working on the Kafka concepts, and hopefully we have a little bit of hands-on experience on Kafka. Still, it's a little upper topic. If you are not interested in Kafka, that's okay. But I think still, if it's optional, it's better to just learn about one more Hadoop ecosystem technologies. Also, let me check both Horton Sandbox and local installation. If I see in Horton Sandbox, because Horton Sandbox kind of is a private company, so if I see it's easier to do experiment over Horton Sandbox, we do over Horton. Otherwise, I teach you how to do local installation of Kafka and work over that. Any questions? So just keep in mind, you have one assignment I haven't posted yet. So it's about using the same text that you imported to your Databricks instance, and you need to predict the title with any techniques that you want. But I need to see 2 techniques or 2 different approaches, like feature selection, SVD, TF-IDF, anything. But at the end, you need to do it in 2 different ways. And you can use my previous Drupal notebooks. As I said, I didn't teach you how to do feature selection in text mining, but it's exactly the same. So if you can just use those feature selection codes that you have a simple data, because when you do tokenization, you have numerical columns. You can do exactly the same thing here. Cool. Thank you very much, and have a good rest of the day. Welcome.